Okay, so in this class we are going to look at math. That's 101 tutorial sheet, of course, tutorial sheet 1, and we'll start from question 5 because that's where we ended with this tutorial sheet. Okay, and question 5 is here, and it reads, which of the following sets are empty? So we have here question 1, question A to C, and they're asking us which of these sets are empty. So we will test them. So we'll check question A. So question A is equal to, so I have, so this is the set of all x such that, then this set is given by the equation x plus 3 equal to 0, and they're telling us that x is a member of the natural numbers. So x is a member of the natural numbers, and if x is a member of the natural numbers, meaning x is part of the set that goes like 1, 2, 3, all the way up to what? Up to infinity, which can be written in interval notation as from 1 all the way up to infinity. So this is the set of natural numbers. And so the set A is given by this equation here. We have to check if this here will give us what? Natural numbers. So you test the x. So you say x plus 3 equal to 0. And I see that this is just going to be x equal to negative 3. So you ask yourself the question, is negative 3, this negative 3 that I have here, is it a natural number or is it not a natural number? So when I look at my set, I see that negative 3 is not part of the natural numbers. Negative 3 is not a member of what? Of the natural numbers. So if negative 3 is not a member of the natural numbers, meaning what we've defined our set A to be here, it's giving us a value that is not part of what? The natural numbers, meaning that this set here is going to be what? To be empty. So our set A is going to just be equal to the empty set. Since negative 3, we see this negative 3 is not a natural number. So meaning it's not going to be part of that set. And our set A requires that all x's that we should find should be natural numbers. But negative 3 is not a natural number, meaning this set is going to be empty. So you can write it like that, or you say, just say A is equal to, you write two braces like this that will have nothing inside. So that will mean that they are empty. Okay, so that's how you do the first one. Then I move on to the second one, which is B. And okay, so B is just the set. So when you look at B is equal to, then I have set of all x such that, so x is defined by the interval, that's from, I have 1, and x is in between 1 and what? And 2. Well, 2 here, as we can see from these signs, the less signs, that negative 1 and negative 2 are not part of this set, because this is just a less than, and it is strictly less than, and we see that it is a strictly less than symbol, meaning that 1 and 2 cannot be there unless if it was a less than or equal to sign. That's when 1 and 2 would have been part of there. Okay, then they're telling us that x is a member of natural numbers as well. So x is a member of natural numbers. So I see what are the natural numbers that are in between here. So I see that if I was to count, there's 1, then there's 2, and it goes all the way up to what? Infinity. These are natural numbers. So now I see that 1 and 2 are not part of them because the symbol that is there is just less than. If it was less than or equal to, meaning that 1 and so if it was written in the way that I have 1 here in front, I have x, and I have less than or equal to 2, this would mean that 1 and 2 are part of that set. But now, because it's just strictly less than, meaning that the set, this set will not include 1 and 2. And if it includes, it does not include 1 and 2, meaning there is no other natural number in between here that can be part of this set, because as you can see, it goes 1, 2, 3, 4, and here in between 1 and 2, there's no natural number that is there. So which means that our set B also is going to be what? Empty. So our set B is empty. Can write it like that. Okay. So then I have part C now. I have to check part C. Is that empty or is it not empty? So I have that it's given by the equation there inside, which is 3x then plus 1 equal to 0. And they're telling us the condition is x has to be a member of, this time is the real numbers. And the real numbers, we know that the real numbers will always run from negative infinity all the way up to what? Up to infinity. So here, this would include all numbers that are what? Rational, all numbers that are irrational, all numbers that can be able to sit on what? On a number line from 0 there, in between going -1, there I have -2, I have 2, I have 3, and all numbers in between. So numbers in between 2 and 3 here, those numbers what will sit there. So numbers like 2.5 will sit here. So I know that 2.5 can be expressed as what? As a fraction. 2.5 can be expressed what? As a fraction. So it will sit there. Also, numbers that are here in between. So in between 0 and what? And 2, or 0 and 1, here you have numbers like half, and half is like 0.2. So this is also a what? A. This is also going to be part of the real numbers. It's a real number. And also, uh, negative as well. Negative decimals are real numbers. And numbers also in between here. Uh, there are a lot of numbers that are in between -1 and 0. There are a lot of numbers here. They will all sit there. Whether it's a fraction, whether it's a decimal, it will sit there. Okay, so those are just a brief recap on what real numbers are. But now, how do we check if this is empty? So we solve this equation, and we have 3x here. Then we take the additive inverse of 1, and that is going to be -1, and -1 will be there. Then I divide this by 3 both sides. Then I have x equal to -1/3. So -1/3 here is what? Is a real number, because the condition is x must be a real number. So -1/3 here is a real number. Thus, the set C is going to, the set C is what? Will not equal to the empty set. So meaning this set C is not what? Is not empty. It has a what? A value which is there, -1/3. Okay, so this is how we solve question 5. Are there any questions as we move on to the next one? All right, so it's quiet, meaning everybody understands. So we move on to the next question, and we have question 6 here. And question 6 is
Sir, you're not being heard.
okay. Thank you very much. Can you get me now?
Yes, we can get you.
All right,
No.
thank you. So, I was talking of a singleton set. So a singleton set is just a set that contains a single element. So remember, there are people that are in relationships. They say they're a couple because they are two. So a single, if you're not in a relationship, you're single. So that means you're alone. So the singleton set is a set that just contains one element in there. So we have the set A, and the set A here, as we can see, is the set of all x such that x is an integer, and the that integer has to be between this value here that's given us, -1 and what? And 1. So -1 and 1 are not part of the set because it is strictly the less than symbol that they've used there. So now you check what is the element that is in between this interval here. what element is in between this interval there. So as we can see here, from -1, if I was to list down the integers, because they've said it's an integer, so I can list it down. So the integers, that would be the integers. Now they've strictly used less than, so meaning -1 and 1 are not part of them. But if they were, then I would have 1, they are 0 and 1. Now the one that is in between there is what is 0. So that's the singleton element they're asking. So listing this out, and what they're asking for is which of the following sets are singleton. So meaning here we'll conclude that the set A is what is singleton, and the set A just contains the what? Contains the element 0, like that. So set A is a singleton set. So set A, this is a singleton set. Okay. So next we have the set B, and the set B is a set of all x such that they're telling us our x is an integer, and our x is defined by this equation there. So I see that the equation that they've given me, so the equation is x squared minus 2x plus 1 equal to what? To 0. And this here is what is a quadratic. This here is what is a quadratic equation. So now I need to solve this quadratic equation. So how do I do that? So I can complete the square. If you want, you can use the formula for you to be able to solve this. So to complete the square on this one, you just say this will be x squared. Then you get half of this value here, half of 2. That is okay. So just a moment. So you just write x alone. So you write x, then you get half of what? This element there. So half of 2, -2 is just -1. Then this you square, then minus, then half of like the -1 which we got here, then we square that -1. So when I square -1, I square it like this, it gives me what? +1, because I'm multiplying negative by negative, and that gives me +1. So then my +1 will come here, then plus the one which is there, and this will be equal to 0. So you better understand this when you take a look at completing the square. Okay, so this gives you this. Then here, no, -1 plus 1 gives me 0. Then I just have x minus 1 squared equal to what? Equal to 0. Then I can take the square root of both sides, like this. Square roots of both sides. Then I just get x minus 1, and this is going to be equal to 0. And I have that x is going to be equal to 1. That's the value that I'm going to get. So x equal to what? To 1. And I see that there's only one value for this quadratic equation, which is 1 itself. 1 is the only value which is there. So meaning this set also, set B, is a singleton element. So you need to be careful. You need to solve this here and see what values it's going to give you. And I know that this one is an integer. So to others who if you look at this and you look at the squared, you'll be like, oh, when the squared there is it's a quadratic it's a quadratic equation, and it always gives you what? 2 values. So meaning this one won't be a singleton. No, you have to solve and you check for real. It's going to give you one value. Is going to give you more than one value, which if it's a quadratic, it would be 2, the maximum values you get. But now we see that it only gives us one value, which is 1 here. So this is a singleton set. So set B also, from this which we've worked out, set B is also a singleton set. So B, which only has the element 1, which we found, is a what? Singleton set. Singleton set. So let's check now set C. So C is defined by this equation here, and the equation is x squared plus 1 is equal to 0. They're telling you that x is a member of the real numbers. That is very important to take note. X is a member of the real numbers. So what do you do next here? When you take the squared here, and you take the 1 additive inverse of what? 1 is -1. You get this here. If I get the square root on both sides, get the square root there, I'll have x is equal to plus minus -1. So now the root of -1 here, I know you guys are doing complex numbers. So this here, you know that this root of -1, this is not going to give you a real number. This is not a real number at all. So I know that this is just x equal to the root of -1 is just what? I. So which is not part of the real number, what? Real number 16. It's a complex number. It's going to be, this is an imaginary number. So meaning it will not satisfy this condition that x should be what? Should be a real number. So meaning this set C is going to be what? Equal to the empty set. It's going to be empty. And if set C is going to be empty, it has nothing. It has no element, meaning that it will not qualify to be a singleton set. So meaning set C, this is not a singleton set. Not a singleton set. Okay. So set C will not be a singleton set. I hope everybody's clear on this. If you have a question, feel free to ask. So this is why set what is not a singleton set. Okay, let's move on and do the last part. So the last part we have is D for this one. So the last part we have is D, and D says X is a prime number. So they're saying set D is a set of all X such that X is a prime number. X is what? Is even. X is a prime number and X is even. So prime numbers, these are numbers that are divisible by X and what? And they're divisible by the number itself and 1. They're only divisible. Only. You can only divide 1 and the number itself into that number. That's a prime number. So these prime numbers begin from 2 all the way. They keep on going. So 2, you have 3, you have 5, you have 7, you have 7, 8, you have 9. Okay, 9 is not. 10 is not. You have 11. So all the way like this. So you can check these numbers. They're only divisible by what? By 1 and itself. And if we're to divide these numbers by any even number, they will always give you a remainder of 1. So these are prime numbers. Prime numbers. Then I have even numbers. Even numbers are divisible by what? By these are numbers that are divisible by 2 and do not what? Leave a remainder. So you have numbers that is going 2, you have 4, you have okay, you have 4, 6, 8, and all the way like that up to infinity. These will be what? Your even numbers. So now they're telling us, so X is a prime number and X is even. So when you look at this definition that they've given here, that is going to be empty because there's no prime. Okay, no, it's not going to be empty. So they're telling us that X is a prime number and X is what? Is even. So you check which prime number is even and which prime number is even. So the prime number that is even is 2. That's the only prime number that is even. Or when you check this, when you continue going, that's the only number here that you find which is going to be what? Common. So meaning the set D is a singleton set that contains the element what? 2. So set D is a singleton set. Singleton set because it only contains 2. So 2 is both even and is what? A prime number. Okay. I don't know if there are any questions here. Okay, so as I said, if you have a question as we continue to go, please feel free, just unmute your mic and you can ask that question. Since there's nobody who's asked, I will move on to the next question. Okay, so the next question, which is question 7. Question 7 just demands for us to identify. So it's saying which of the following sets are finite and which one are infinite? Which of the following sets are finite and which ones are infinite? So I must check now. So a finite set, a finite set is just a set which is countable. The elements in this set are what? Are countable. So if I have a set, for example, if I have set A equal to 1, 2, this is a finite set because I can count. these elements that are here. So I have only elements that's 1 and 2 in there. So the number of elements there is 2. So I can count these sets. But then there's an infinite set. An infinite set is a set which I cannot count these elements that are in here. For example, the set that we are writing here, like from 1 towards to infinity. So this is a set of natural numbers. It's a set of natural numbers. Set of natural numbers go up to infinity. I can't count this set because I don't know what infinity is. When I can start here, 1, 2, 3, 4. I will continue counting, but I will end somewhere for myself. Even computers will end somewhere because of how they've been programmed to count. But numbers will continue to go. We don't know what infinity is. So now we need to identify which ones are what are infinity. So, okay, how do we do that? So let's start with the first one. So the first one is given by, so it says set of OX such that X is an integer. So X is an integer. If X is an integer, meaning we can count these here, values that are there. So I have, they're telling me from -2, and they've used less than or equal to, meaning -2 is part of that set, and I have X less than or equal to 1. So I can even list down these elements that are there. So they're starting from -2. I have -1 there, I have 0, and I have 1. These are the what that are in the set there. So this set here, I can even count these 1, 2, 3, 4. There are 4 elements in this set, which means this set is a what? Is a finite set because it has a finite number of elements which I can easily count. So the first one, we will conclude that this here is a finite set. Finite set. Okay, let me check now for number 2. So number two, they're telling me, so it's the same, but now, so if you can see, it's the same, but what they've changed is the condition. X is a member of the real numbers. The first one was X is an integer. This one here, X is a member of the real number, but the same interval like this. X, that included. So now, real numbers here, anything that I'm going to be picking in between here, any fraction. So imagine now any fraction that's in between there. For example, I have, so there's -2 there. I know if I was to get the next integer is -1. So anything in between here. So let's say that's -1.5, right? -1.5 is in between here. And -1.5 can be written as 3/2, -3/2, like this, as a fraction. So any value that I'll be getting in between here. So I can be getting any value there as long as I am able to get a decimal there. So I can have like -1.1, -1.12, -1.1. So here there'll be a lot of numbers. So -1.1 is different from -1.123. So there'll be a lot of numbers, especially the decimals, the fractions. There'll be a lot in between just -1, -1 here and what, and -2. So I see that for the real numbers this time around, because real numbers, the set of real numbers. So if we have natural numbers, we're saying natural numbers are a subset. So subset of what? The integers. And the integers are a subset of the rational numbers. Rational numbers are numbers that can be expressed as A/B, where B is not equal to 0, meaning they can be written as fractions. Then these are also a subset of what? Of the real numbers. We see that all these here numbers can be in between just this -2, -1, and -2. There can be a lot of numbers there. So meaning that this here, our set, is not going to be what? Finite. Instead, it's an infinite set because there are going to be a lot of numbers there. We cannot even list the numbers that are there because there are a lot of them. So this set here, number 2, we conclude that it's an infinite set because I can't count the numbers that are there, the real numbers that are there. Okay, the third one is given as an interval. So when they are given as an interval like 2, 4, they're just telling you numbers that are in between. So if I was to plot on a number line, I have my 2 here, I have my 4 here. all numbers that are in between here, apart from 2 and 4. Again, here, there are a lot of numbers. So they've not specified really. Of course, if they do not specify in this case where X belongs, then they're talking of X being a member of the real numbers. You take it that they're talking of X being a member of the real numbers. So like it is given here, X is a what? A real number. And as we were from explaining, there are a lot of real numbers here. Any fraction that is going to sit in between here, any decimal, and I'll just be adding like a bit more. So I know that I have a 0 there in between 0 0.1, I have 0 0.12, 0 0.112. There are a lot of numbers there I can give that are going to be there. And that means there are going to be infinitely many numbers there. So this here is going to also be an infinite set. So we conclude that this set is also an infinite what set. Okay, this also is an what? Is an infinite set. So okay, so that is it for question 3. This is infinite as well. Then I have question 4. So question 4, that the condition is, so it's a set of OX such that X is a natural number. X is a member of the natural numbers. And they're telling me that X is in between -2, like this, and 8. -2 and 8. So now, the natural numbers that are there, I can actually count the natural numbers that are what? That are there. So, I have here, if I was to list down this set, so, and they're telling me, of course, natural numbers. Let me list down what is not in the set, but what is in this interval. So, -2 and 8 are not part of the interval, but I'll be listing them as integers. So, I'll list -1, here 0, 1, 2, 3, 4, 5, 6, 7, and 8. Like that. Now I check the natural numbers. So natural numbers begin from 1 all the way up to what? Up to infinity. These are natural numbers because the condition is X must be a natural number. So now from 1 going all the way up to here, they're telling me so to be 1 up to 8. So this set here given, question part 4, is just the set that contains the elements 1, 2, 3, 4, 5, 6, 7, and 8. And I've counted these numbers here. So meaning this is a finite set. Sorry, not an infinite, but it's gonna be a finite set. Finite set. Okay. I heard somebody was about to talk. Do you have a question? Anyone with a question before we continue? If you have a question, feel free. Okay, there's no question. So let's continue. We have then part 5. So part 5 is just -3 to 7 like this. So again, we use the same concept. -3 and 7 are part of the set, of course, because I have square brackets here. But in between these numbers, there are infinitely many numbers. So this is going to be an infinite set. And same will imply to the last one, which is this one here, from negative there, infinity to 0. These here, in between here, there are a lot of numbers here. So that is going to be a lot. And this is going to be infinite because we can't count those numbers that are there. So this is going to be an infinite set. Okay, before we move on to question 8, do we have any question here? All right, I do not have any question. Okay, thank you. So let's move on to the next question. And the next question is this one here. And it's just asking us to, okay, it's asking which of these pairs of sets are disjoint. So disjoint sets, so if you have a Venn diagram like this, then you have two sets, one and this one. You have A and B. They are not joined. So if they are not joined, meaning they're disjoint. So these sets here are disjoint sets because they do not have any common elements. There are no elements that are common to these sets. So that's what is making them disjoint. So, but if there were elements that were common, then it would be joint. But because there are no elements that are common, then it's disjoint. So we can check these elements. Let's check these sets, these two sets, I mean. We have A and B there. Do these sets have anything in common? I have 3, 5, 7, and 9 there. I have 2, 4, 6, and 8. So those are different elements altogether. So they'll be disjoint. And when you write them or write them in a Venn diagram, you can write them like this. So I have 3 here, 5, 7, and 9. Then in the other one, I have 2, 4, 6, and what? And 8. These here are disjoint sets. But I can check the next one now. So the first one I conclude, this one is disjoint set. Then the second one, I have P and I have 3, 5, 6, 7, 8, and 10, and I have 4, 9, and 10. So which one of these, which elements are common? So it has a common element, which is 10. So 10 is in both sets, meaning this one here is not going to be a disjoint. Instead, it's going to be a joint set because it has a common element. So here I can write them here and there. So I have P here and I have Q there. And the common element I have is what? Is 10. So 10 will sit there. So it's in the intersection. Then the remaining of elements, so you have 3, I have 5, I have 6, I have 7, and 8 will sit there. Then here I have 4, and I have what? I have 9. They'll sit there. So this is how this set is going to what to look. So this set here, but 2 of the set, this one here is not disjoint. This is not disjoint. Or you can write it is joint. It's a joint one set. This one is not a disjoint set. Okay, so this is how you show that one. Okay, is everybody clear on this one? All right, so we have the next question. It's a true or false question. And it says true or false. If A and B are two non-empty sets. So if there are two non-empty sets, meaning A and B contain elements. So there are elements. You expect elements in A and you expect elements in what? In B. And they're saying the other condition that, so two non-empty sets, A and B, and the intersection, they're telling you the intersection of A and B is equal to the empty set. So meaning the intersection here, like we had that diagram like this. I have a set A and a set B, so A and B. So set A and B, like we had previously, here, as we can see, these set A and B, they do not have anything in common. So meaning their intersection is what? Here is empty. They have nothing in common, so the intersection is empty. So then now we go back to this question. True or false? If A and B are two non-empty sets and A intersect B is equal to the empty set, then A and B are disjoint sets. So is it true? Is that false? Okay, we can answer. Is that true or false? Yes. Anybody to just answer? It's just true or false. Just say true, false. You can unmute your mic and say. Okay. Am I even audible? Can people get me? I see nobody that is responding. Okay, so the purpose of the live section is for the interaction. So if you guys are unable to respond, it's going to be hard on us. Nobody, okay, see nobody's unmuting their mic and speaking. So I will take it that I don't know. So this here is going to be what? To be true. So if these conditions here that have been given are satisfied, then the set is going to be what? Disjoint. So meaning this here statement is a true statement. It's going to be true. Okay. So I have less than a minute for my class to for this link to close up, or for this meeting to close up. So if it closes, just rejoin using the other the same link, I mean. Okay. let's continue and state the cardinality and write down the power set of each of the following sets. State down the cardinality and write down the power sets of each of the following sets. So first of all, you have to understand what cardinality is. So cardinality is just the number of of elements that sit in your set. So number of elements in your set, and it's denoted as NA like this. Number of elements in the set A. That is cardinality. Then the power set, you have here power set. So a power set, this is the set of all subsets that you have in your set. And this power set, for example, power set of A is given by the formula we have 2 to the power at n, where n is just cardinality.